Hello everyone, welcome back to another video with Mr. Coder, and in today's video I'm going to show you how to solve new game question C from Educational Codeforces Round 170 rated for Division 2. So there's a new game Monte Carlo wants to play, and it consists of n cards, where the ith card has exactly one integer AI written on it. And at the beginning of the game, on the first turn, Monocarp can take any card from the deck. And during each following turn, Monocarp can take exactly one card that either has the same number as on the card taken on the previous turn, or a number that is one greater than the number on the card taken on the previous turn. So in other words, if he took a card with number X, he can take a number with a number X or a card with number X plus 1. And he can take any card which meets that condition, regardless of its position in the deck. So that itself hints at sorting that without order, because order doesn't matter. And then after Monocarp takes a card on the current turn, it is removed from the deck. And according to the rules of the game, the number of distinct numbers written on the cards that Monocarp has taken must not exceed K. So you cannot have more than K distinct numbers. And then, if after a turn Monocarp cannot take a card without violating the described rules, the game ends. You have to determine what's the maximum number of cards that Monocarp can take from the deck during the game, given that on the first turn he can take any card from the deck. And notice that n is less than or equal to 200,000, which means that n squared of n squared will not work. So it's always good to look at time complexity in these cases. So for the first one, you cannot have more than two distinct values. And using the sorting hint, it's 2, 2, 3, 3, 3, 4, 4, 4, and then 5, 5. So then what's the maximum amount of cards that he can pick? That's plus 1, and then it can either be plus 0 or plus 1, the next card. So what's the maximum? It would be 3, 3, 3, 4, 4, 4, which is 6 cards. And he wouldn't be able to do any more than that because then it'll violate the two distinct numbers rule of K. And then if we look at this fourth test case, there's 1, 3, 1, and it's not 2, even though the number of distinct values is 2, because you have to realize that, well, it's not 3 with like all the cards, even though there's only two distinct values, because the difference between these are plus 2, and you have to take a card with either X or X plus 1, such that X was the previous turn card. So using this, we can think that this is like a 2 pointers problem. So we can just use a normal 2 pointers, so with left and right, and then you have the current best is equal to 0 for the number of cards. And then you can use a set and a map to see how many distinct numbers there are. Map will help you determine how many are left, because multi-set can't help you find the number of distinct values, but you can use set and multi-set as well. But I mean, map is more straightforward for me. So first thing you do is you check if you want to check to make sure if the current one that you're trying to add, if that minus the previous one, if the difference is greater than or equal to 2. If it's greater than or equal to 2, then you need to start a new group. So you clear the set, clear the map, and you set the left boundary is equal to R. And then you can start inserting the current one into the set and the map. And then while the size of the set is greater than K, then you want to keep moving the left boundary closer to R. So you subtract it from the map. If that value is equal to 0, then erase it from the set and add 1 to the left boundary. And then you update the best with R minus L plus 1. And then at the end you just print it out. So this is basically almost like a classic 2 pointers problem where you just have one pointer and then you test the other one. So yeah, this is just 2 pointers. So yeah, that's how you solve new game question C from Educational Codeforces Round 170 rated for Division 2. So yeah, thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next one. Bye.